Hello everyone, welcome again. So today is a follow-up video to one of my previous video, which is under the name of storing variables in the MCU EEPROM. Okay, so if you see the video now, we can see I'm storing some variables, okay, inside the EEPROM of the Arduino by using write command. Okay. Okay, we can see here we are storing some data by using the EEPROM library. However, this method is not really an optimal way to do this, and today we will learn how to do this correctly. Why? Because when we use write, we always overwrite the previous data in the EEPROM, whatever it's the same or no. For example, now I want to store I in the address number 0 or location 0 inside the EEPROM. Okay, so these are, for example, now I is equal to, let's say, 10. I store it in 0, place number 0. So next time, let's say, after I do some, I will go for iterations, or it will go for some different thing inside the code. Let's say the I still come back here and I is still equal to 10. When come to here, write will still write 10 inside the 0, which even though previously it's 10. And if we go and check the data sheet for the MCU, which is the Atmega MCU. Okay, this is the data sheet for the Atmega, and for Arduino Uno they use Atmega 328P. We can see here the EEPROM for the Mega. I believe for Arduino it has 1 kilobytes of EEPROM, and it has a limited number or cycles of writing and erase. For EEPROM is about 100,000 times or cycles. Okay, so instead of we directly write the data or override the data in the location of the memory, we will use an alternative code to first check the data if it's still the same, so we will maintain, no need to overwrite it. If not the same, then we update it. Okay, with this we will save what we can save from the EEPROM writing cycles. Okay, and now we will see how we implement this method. Okay, so here I already open a new tab for Arduino. So here I already connect my Arduino to my computer, and I connect the boot to a potentiometer to analog pin 0. Okay, so first of all, let's display the potentiometer data. First we try to define or implement the serial.begin. We use 9600 for the baud rate, and then inside the loop we will define an variable to integer data equal to analog read from the A0, and then we print it. Serial.println. We print the data, then let's add some delay. first reboot here, say 10 milliseconds. Okay, let's send and see. Do you want to save? No, thank you very much. Okay, it's uploading and done. Okay, so if you go now to tools, serial plotter, now we can see. Okay, this is my potentiometer. I'm rotating it now. Okay, nice. So this is my potentiometer now. Now let's say I want to save this value. Let's say now I'm rotating it. I want to save this value. So no need to every time I run the code, I have to rotate the potentiometer, but it will be automatically recall this data or retrieve the data from the EEPROM inside the MCU. Okay, let's do this. Okay, so first of all, and since we are using the EEPROM of the Arduino, so we need a library called EEPROM, which include EEPROM. This library already included inside the Arduino IDE. No need to add anything. I mean, no need to be installed. Okay, so first of all, let us see what is the maximum length of the EEPROM of the Arduino. So in the setup, we call serial.print line EEPROM dot length. So okay, so this one will return the EEPROM length, and here we don't need this data now for the time being. Later we can treat. Okay. Now. Okay, as we said, for the Arduino Uno, the maximum length or the size of the EEPROM is 1 kilobyte, which is 1024. Okay, thank you very much. So this one we don't need it anymore. Okay, so now, as we said, first we will take this data and store it inside the EEPROM, then we recall it again. So how we store this? Okay, the idea is to store, let's type here, we have to read the data from the potentiometer, then store it in the EEPROM, then we will retrieve it back and print it to the serial. Okay, so we have to do this. So first of all, usually I like to add some command to the user, or command to, it's not command actually, to print some instruction on the screen by using serial monitor. So we print serial.println starting data recording in 3 seconds. Okay, it's just the user will be prepared to rotate the potentiometer, start to record them data. Then we add some delay, let's say 2 seconds. Then we repeat this. Okay, 2 seconds and 1 second. Okay. After that, what we will do, we need, as we say, so now we knew here that the length of the memory is 1000 byte, 1024. So here we need to loop through these locations. We use for address equal to, I'll start from 500, address less than or equal to 1000, and address plus plus. Okay. So now what to do here? First, we will read and store the data. Let's read it first. First, we need to read it. How to read? We use this instruction. Let's cut it. Okay, here we read the data and print it. Now we need to store it. We cut. Okay, now we need to store the data. How to store the data? Instead we use of EEPROM dot write. Okay, instead of this, it's better we use EEPROM dot update. Okay, this one actually it will read. Okay, first it will perform the read instruction. If this read instruction is not equal to data, then it will write. Okay, so directly we use update function. Okay, update function, it takes 2 arguments, the address and the date. Okay, but the data here, be aware that this every location of the memory, it takes 1 byte. It means 1 byte maximum of 255 of data. And here, this analog read, it will return at maximum, or the range will be maximum from 0 to 1024. So here we will have problem. So we have to divide the data of 4. Okay. Again, we need the delay for stability of time. Okay. After that, so now we have complete this. We store all the data. We need to retrieve and print it back on the serial. How to do this? Okay. Again, I need to inform the user we have done. Let's copy this back. Let's see here. We inform the user that we have done the recording. I guess we don't need this. Now we are replaying. Okay, to replay back or recall or retrieve. Okay, yes, here we need to retrieve. Okay, how to retrieve the data? Again, we need the for loop also. For integer address, again from 500. Same what we say here, from 500 to 1000. 500 to address less or equal to 1000, address plus. Okay. So now we are retrieved back. To retrieve the data, we need to define another variable. Let's go integer data2 equal to EEPROM dot read from the address. Okay, then we need to print back to the serial. It will be inside the loop. Serial.print data2. Let's add something. Okay. Yep. Let's test this code. Upload. Thank you. Don't want to say. Okay, done. So when we open the CL monitor, it will tell us, okay, start in 3 seconds, 2 seconds. Let's be prepared, 1 second, and okay. You see, now I'm changing. Okay. Now the recording, now it will be playback again. Replaying. Here it's print like this. It's wrong. We should print line here. And also I have found another mistake. Let me tell you what is it. Okay, done. Open. Okay, 3 seconds, 2 seconds, 1. Here we go. Start. Okay. Let's rotate. Okay, done. Now replaying. Now should be print line. Yes, correct. Here we go. I'm changing again. Actually, I'm not touching anything now. It's autoplay. But here is it. The problem. It will start again. Why? Because we put everything inside the loop. Actually, this is wrong. We shouldn't put inside the loop. Well, sorry, we shouldn't put everything inside the loop because it will be overwrite again and again. So we have to perform this one for once only. Then it will be always read the one we store. So to solve this issue, let's use flag. Let's flag it. We use boolean flag equal true. And we want to run this only if the flag is true. I want to run this once. This will be run once. And this one also, let's be run once. Okay. Yeah, that's all. Upload, thank you. Okay, compiling, done. Thank you very much. Thank you, Arduino. Okay, 3, 2, 1, go. Okay. Okay, now it's recording, done. Recording, thank you, replaying. And yes, this is our saved data. It's replaying now. Shit, why is this? Okay, sorry, it's my fault. Actually, since we flag it here, we should break this condition by adding, this is for if, yes. So after this, we should break the condition by make the flag equal to false. This should work now. Okay, upload. Thank you, I will do it. Okay, now, okay, 2, 3, 1, and go. Okay, we go here all the way to up and down. Now, done. Replaying back, and boom. Now we shouldn't expect any looping back of the code that we flagged. Okay, to see this obvious, I suggest to go to CL plotter. Okay, so here may be asking because I cannot see what's printing, but I'm still okay. So I'm rotating now. Okay, then now it's done, finished. Now I left the potentiometer, and here we go. But we can see a problem. We can see a problem. Have you noticed it? Let's repeat again and see the problem now. The small problem. Okay. Let me wait. Okay, you see now I can go up to 1000. Go down. Okay, see, can go up to 1000 this peak. When I play with the potentiometer here, it can go up to, you see, 255 as we say. Because why? Because the ROM, the EEPROM will start 255 maximum. So to solve this issue, actually we already solved it by dividing. When we store, we divide it by 4, but here we forgot to multiply by 4 again when we retrieve it back. Okay, let's see. Okay, CL plotter. Okay, it's asking to wait for 3, 2, 1. Okay, go up, down, up, down. Now you can see the data. It should be still maintained until to 1000. Yes, you see now, full scale. Beautiful. And see, it's repetitive now. Even though I changed the potentiometer, it still doesn't affect because this one purely from the data we stored before in the EEPROM. Beautiful. So now I can record any data I want and it will record for me forever. Okay, with this I'm saving a lot of time or a lot of cycles from the EEPROM, because as we saw before in the datasheet, the writing and erasing cycles is very limited compared to the unlimited cycles of the reading. So the safe way to store data is first we read the data inside. If it's the same, no need to update or no need to write. If not same, we need to store the new data. Okay, so with this we have solved the issue of writing, and hopefully we are prolonging the cycles of the erasing and writing to our EEPROM. Okay, so this function actually already implemented inside the Arduino Uno for the EEPROM, for the Arduino Uno EEPROM by using update function. But later we will learn how to do exactly the same ROM, but exactly the same function, but for the external EEPROM. Okay, so with that, I guess I am finished for this tutorial. I hope you have learned something. Please let me know in the comment down below if you need any further help or if you face any further issue. Thank you very much. See you soon.